Okay, so we're on the last section, area of a triangle. So sometimes we're given a triangle on a coordinate grid and we have a different formula for finding the area of it than half base by perpendicular height. So this is a very handy formula. So if we have a triangle with one of the vertices at 0, 0 and the other two vertices can be anywhere else, the area of the triangle is a half. And this symbol here means modulus. It means whatever answer we get in here, we take the plus, even if it's a minus. So we calculate what's in here. If it's a minus, we change it to a plus. This is called modulus or absolute value, these lines. You would have seen them when we did distance PQ or distance AB, because distance is never negative either. We always take a plus, but in the distance formula it kind of is done for us because of the squaring. Alright, so here we have to just be mindful that we take the plus and then half the answer. Now, if one of the points is on 0, 0, it's all very straightforward. It's just applying the formula. So this is my x1, y1. This is my x2, y2. My 0, 0 doesn't come into it, okay? So the formula is a half x1, y2 minus x2, y1. So a half x1 is minus 2, y2 is 4, minus x2, which is 3, y1, which is 1. So what we do is we get our calculator and we type in what's inside the modulus, okay? Leave the half out of it for a minute. Okay, type in what's inside the modulus, get an answer. The answer is minus 11. Okay, but this means take the plus, so we're going to change it to 11, so half 11 then is 5.5. And it's area, so it's units squared. Sorry. So 5.5 units squared. The only difference then is if none of the points are at 0, 0, we move one to 0, 0. So let's say these are my points of my triangle. I can move the whole triangle the same amount. So what I'm doing is I'm just moving it down. So if I move 2, 4 to 0, 0, what did I get to 2 to get to 0? I had to take away 2. What did I get to 4 to get to 0? I had to take away 4. So I need to do the same to all the other things. So it's 7 take 2 leaves me with 5. 3 take 4 leaves me with minus 1. 4 take 2 leaves me with 2. 1 take 4 leaves me with minus 3. So they're my new points then. Alright, so you look, what do I do to the x to get to 0? What do I do to the y to get to 0? And I do the same to the other 2 points. So then that gives me my x1, y1, my x2, y2. Okay, so x1 is 5, y2 is minus 3, x2 is 2, y1 is minus 1. Again, we do what's inside the modulus first. So 5 by minus 3 minus 2 by minus 1. Okay, and that gives me minus 13. So a half of minus 13. Now we change the minus to a plus and we do a half of 13, which is 6.5. And again, it's units squared. Okay, so there you have it. You move your point. So for example, in this one, it doesn't matter which point you move. I'm taking 2 from the x, I'm taking 4 from the y. Again, that's the same as our last one. So to move this one, I take 2, I take 4, I take 2, I take 4. So 2 take 2 is 0, 4 take 4 is 0. So once we have 1, 0, minus 3 minus 2 is minus 5, 1 minus 4 is minus 3, 3 minus 2 is 1, and minus 5 minus 4 is minus 9. And off you go again with your formula. x1, y2 minus x2, y1. This is x1, y1. This is x2, y2. So x1 is minus 5, y2 is minus 9, x2 is 1, and y1 is minus 3. So again, just put what's inside the modulus into your calculator. Minus 9. Get 48. So if it's a plus, it's fine. It's just, if it's a minus, make sure to change it. 24 units squared. Okay, sorry. Okay, so exercise 3.10, page 72, try questions 1 to 7. Let me know if there's any problems.